Hello, hello. आ रहा है क्या?
Okay, are you able to hear me now? My microphone was off. I'm sorry. All right, fine.
Yes, sir.
Okay, great. So I was discussing about the different kinds of operators that we had started studying yesterday, right? In the context of
Yes,
that,
sir.
uh, I would request others to please mute your microphones. Yeah. So we will quickly touch upon the relational operators for a while, and then we will move on to the next operator and then to the next chapter. So I am giving you a small example here. If you look at this example, I have declared three variables and it's X, Y, and Z. And it's very easy to understand the different types of these variables which are going to be here, right? So the first one is an integer, second one is an integer, and third one is a float. Now, if I do something like this, can you tell me what will be the value of this? What will be the value produced by the program? What will be the output produced by the program? Anyone? What do you think will be the output which this expression, this statement will produce?
False.
So what is the
Sir,
value
not
which is
for
what is the value which is going to be produced? Obviously, this is incorrect or this is false. So I told you that the relational operators and expressions produce only two values, that is 0 and 1.
0.
So 0 will be produced here. Okay. Similarly,
Yes.
let me write another expression here. What is the value that is going to be produced here? 0 again, right? Suppose I write x is less than z. Is this statement true? Yes, this statement is true. So what is the value which is going to be output here? 1,
1.
right? Similarly, if
Yes.
I do y is greater than z, then again we will get the value 1, right? Now, if I write the statement this, what is going to come?
Is not
If I
true. Why is it not true?
y
X
is
is equal to not
25,
true. Y.
so x is not equal to, this is not equal to. Yeah, somebody, hello, please mute your microphone. Please mute your microphone. Okay, so
Zero.
here, what will
False,
be
false, sir, false. 0. 0.
0, right? Okay, brilliant, very good. Okay, and the last one. Once you answer, you can just switch off your microphone after that. What do you think will be the answer here?
Sir, false. 0. 0.
0?
1.
1.
Yeah,
Yes, sir.
1?
1.
Yes,
1.
1.
absolutely. Good, very good. All those who said 1, very good. So you can see exactly that what is going to be the output of all the expressions which involve the relational operators. And that's the point which basically I wanted to raise it out here, that no matter what, how complex your expression is, no matter how complex or how long or how many combinations of expressions you have with these relational operators, the output of that expression is only going to be 0 or 1, or in other words, false, true. Okay, fine. Now let's look at one operator which we know as the cast operator. Okay, what is this cast operator? Now this cast operator is an operator which is basically going to help us, right, in changing the type of a data type. For example, I'll write a small program and then I will explain it to you so that you can understand. So what I'm going to do is I'm going to write a small program. So all these hash include stuff I'm going to write first. Okay, so here you go. My hash include is ready. Let me bring my main method. So here is my main method. All right. Now let me declare two different variables. So I have x and y are both integers. All right. Now let me give a value to x. So let me say that the value of x is 7. Okay. And also let me write the value of y as say 5. Okay. Now I'm going to print something. So I'm writing this print statement. Everybody is okay or aware of what I'm doing here. So let's say if I have given the value of x as, here is my format specifier, right? And I'm writing d because I want an integer, and y is also given as an integer, right? And this is the new line, and here you go, the x and y value. So I think everybody is okay with this statement. Now I'm going to write something here. So here is printf, and I'm writing x divided by y produces, okay? And now what I'm doing is I am writing d here, which means I am giving a format specifier for an integer itself. Okay, and I'm actually doing the calculation here, x divided by y, right? So whatever is the computation of this statement will get printed according to this format. Okay, and then I am writing another print statement. Now this is where I am going to do some kind of casting. So this operator I'm going to use. All right, so here I'm going to write, this is just a statement, so I'm going to write float. This is not an expression, this is just something to that I'm going to output. Okay, that I'm just going to output here. So don't think that the calculation is happening, because these are all within double quotes. So will produce what this will produce. This will produce. Now here I am putting a floating point format specifier. So the format in which my number I want is going to be a float. Now this is important here. Now here I am using the cast operator. So how do you use the cast operator? So in order to use the cast operator, you need to write the data type. So what I'm doing here is I'm converting an integer to float. Okay, so I'm converting an integer to float. So what I'm doing is my integer is x5y, right? So rather than doing this, I'm going to convert the x value into a floating point number, and then I'm going to divide it by y. All right, now let me return, and we will look at the output now of what exactly is going to happen. So here my program ends. Now, if I take out the output of this program, right, now what is going to get printed? First of all, this line will get printed, and in this statement will get printed. So given x is equal to 7 will get printed, and y is equal to 5 will get printed. So x is equal to 7 and y is equal to 5. This is what is going to get printed in this line. That's very simple. Now the second line is where I'm interested in. What do you think will be the output of this line? What will be the output here? Can anyone tell me?
1.
Very good. The output is going to be 1. Why is the output going to be 1? The output is going to be 1 because here x divided by y, which is 7 divided by 5, is actually 1.4. Okay, 1.40. But because this is a floating point number here, right? But what I have declared here is an integer. So my format in which I want to print this result is an integer, but what I have here is a floating point number. So it's something like this. I have two containers, one container and another container. Okay. So this container is a large container which contains a floating point number. So here you have 1.40. Okay. Now this I'm trying to put it inside a smaller container which is of integer type. So what happens if you have water here and you fill that inside a smaller container? What is going to happen? This is going to get filled up, but there are some portion of this water is going to spill. It's going to spill. That means I'm going to lose some data here. Some loss of data is going to happen here. Similarly, that's what has happened in this case. So I have a floating value of 1.40 here, but this, when I'm trying to print it into a format specifier which is given as integer, then I only have the integer part of it. This part, that is the real number part of it or the decimal part of it, is lost. So 0.4 disappears, it's lost. And what I get is 1. So this line will produce the value 1. Okay, so I hope everybody is clear with this. Now let's look at the third line. What am I doing in the third line? In this third line, I have used an access specifier. All right. So now what happens is this here, okay, this cast operator. Now this is a cast operator. So this float that I'm writing within brackets is basically called as a cast operator. So you can have different data types here as a cast operator. This converts the value of x to a floating point number. Okay, this converts the value of x to a floating point number. So as soon as this becomes a floating point number, right, this whole expression by default, so floating point number divided by 5 will become a floating point number. So this whole thing will become 1.40. Okay, this will become 1.40, and this 1.40, now I have percentage f. So percentage f, basically it's a format specifier for printing the floating point number. So what will happen is, in this case, I will have a value which is 1.400000, which will get printed out. Okay, the reason this will get printed out to so many decimal places because of this percentage f. A floating point number will have these many precisions by default. So you will have a total of 6 places of decimal after 1. So you will have 1.4 and you will have 5 zeros here. So this is what is going to get printed out. So the whole point of doing this program was to understand this small thing called as a cast operator, a cast operator. Okay, so don't have to worry about too much about this program. Just remember that we have something called as a cast operator which converts your data types into one form to the other. Now what, there is a rule, or there's a simple logic. Let me explain that logic to you. Okay, if I have an integer, that means this, and if I want to convert it into a float, that means a float holds a larger size. Float is basically a data type which has a larger container. Integer is a data type which has a smaller container. So if I'm trying to convert an integer into a float, so how am I going to write? Here is my float and here is an integer. So this is basically my cast operator here. And by this, whatever integer value is here will get converted into a float. So what I'm saying is this integer will get converted into a float. Now, if there is a value 5, it will change into 5.00, whatever. Okay, now this is absolutely correct and there is no problem here. The reason there is no problem here is because anything which is there in a smaller container can obviously go and get filled into a larger container. There is no loss of data when you are taking a smaller container and taking the contents of the smaller container and putting it into a larger container. There will be no spillage. Okay, spillage. There will be no spillage because the container size is big enough, large enough to accommodate all the data that you have here. So there is no spillage. But if you do the opposite, that means if I have a small container and if I have a large container, and if this contains a floating point number, and this is an integer which contains, it's a smaller size, So if I'm going to pour the container of float into an int, there will be spillage. Spillage means there will be some data will get lost. Okay. So if I go and do float and if I do int, this is correct because there will be no loss of data. But if I do this is not right because your data will change and there will be a loss of data. So if you do something like float and if you write double here, if you have a double value, will there be a loss of data or there will be no loss?
Is it float to double or double to float?
What do you think? I'm casting, right? So this number is going to be casted into a float. So will there be a loss or no loss?
So there would be a loss of data.
Absolutely. There will be spillage. Why? Because double has got a larger capacity to larger container. Float is a smaller container. So if you're going to convert this into this, there will be loss of data. Are you able to understand this? So if I do this an integer, will there be a loss or no loss?
So both are of different types.
Yes, character and integer. So
No
suppose
loss, sir. No loss. No loss.
in this case you are trying to put a integer into a character. Integer has a larger size than the character. Integer,
Yes.
let's say if it has a 4 bytes, this will have only 1 byte. So you're taking the all the data from which is being stored into 4 bytes of container into 1 byte. So there will be loss here in this case. But in this case you have a character which is a small container and you have a large container which is an int, and here there is no loss. Is this clear?
Yes, sir.
Okay,
Yes,
so
sir.
it's very important to understand this because in your program normally we tend to make a lot of mistakes. There will be many times where we need to do casting, right? If you don't do casting, there will be an issue, right? So there are many times that you have to do this casting, and when you're doing this, you must be absolutely sure that you are not going to lose the data, because if you have a data loss, then there is an issue. Then the whole purpose of writing that program is going for a toss, because if your result is going to be incorrect because there is some loss of data because we did not handle the data properly, then there is a problem. Okay, so in this first introduction to operators, right, we
Sir,
discussed, yes.
sir, what if we have a loss of data for our benefit only?
No, I mean, if you want to have a loss of data, then there's no problem. If you think that, yes, I want only the integer part and I want to, remove that other part, then yes, that's fine. If your requirement says that you need to have a loss of data, then it's fine, no problem. Okay. But the whole point is that what exactly do you want? It should not happen that you are expecting a result based on some calculations, but internally there is some loss of data because somewhere accidentally you are putting a smaller variable in a larger variable into a smaller variable, you know so there will be an issue because the answer will not be incorrect. But purposely, if you want to go and do it because there is some requirement which requires this, then there is no problem. It all depends on the logic that you have. Okay.
Okay, sir.
All right, so let me just summarize what we have done, in the context of operators. We have just touched upon operators today. And what I have actually told you about operators is, in order to manipulate the data, we need these operators, right? So today was just yesterday's class, and today's was just the touch of operators. We just talked about the assignment operator, and we also specified that an assignment operator has got two operands. So every operator has got operands. So whether the operand is on the right hand side or the left hand side, again depends. For example, in the assignment operator you have two operands on each side, but when you talk about the decrement and increment operator, you can either put the operand in on the right hand side or the left hand side. Okay, so what we learned was this assignment operator. Then we also discussed about this, right? About the different arithmetic operations, right? We discussed about the different arithmetic operations. We also discussed about this operator and this operator, which is increment and decrement. You know that it happens +1 and this happens -1 happens here, right? And in context of this, we discussed pre and post. So these are two important things that we discussed, right? There are two versions of the decrement operator, two versions of the increment operator, the post and the pre, all right? And we also touched upon the 6 relational operators in C. The relational operators are those operators which are useful in evaluating expressions, right? Which are useful in evaluating expressions greater than, less than, equal to, all that stuff. And an important point that we learned is the value which comes out of your relational expression is always either 0 or 1, which is represented as true and false. Okay, 1 represents true and 0 represents false. Now, why this is important is because this will be used in defining our conditions. Like when we start, I don't know whether you remember or not, you can go back to the first class that we discussed. And I talked about 3 important things. I talked about writing statements, right? I told you that the programming is very simple and the entire program can be concised into 3 different components or 3 different thoughts. One of them is your statements or your single instructions, right? Second one is nothing but the branching. That means you can write these instructions depending on a condition. So here is my first instruction. So if this is 1, 2, 3, 4, 5, 6, 7, these are 7 instructions. I can write 1, 2, 3, 4, 5, 6, 7 instructions, but each of these instructions is basically depending on a condition. So this is called as branching. And the third one I told you was looping, right? Looping means you have 1, 2, 3, 4, 5. These instructions will keep getting executed until a condition is met. Until a condition is met. So you keep loop through all these expressions one by one, loop through these instructions one by one until a condition is met. So in order to evaluate the conditions, we will need the relational operators. For example, if A is less than B, then keep doing this. Okay, so this is what? This is basically your relational operators. What is the value which is going to be out here? Either you'll have 0 or 1. So we are going to check whether it is true or false. So when we talk about true and false, all the conditions that is related to looping will involve your relational operators. So relational operators are very important with looping. Okay. Is anybody does anybody have a question, or can we move ahead? I think somebody's microphone is on. If you have a question, please ask. If you don't have a question, you can mute your microphone. Okay, so assuming there are no questions, fine. So there are certain questions that you can think about from this chapter, which can come in your exam or which people can ask you in your interviews. It's like, what is the difference between the pre-increment operator and the post-increment operator? Some, you know the answer to this. You can also give an example, right? You can also talk about, what are the values which is yielded by a relational expression. So that means if you are using a relational operator to evaluate a relational expression, what is the value that is output? So the relational expression evaluates to either 0 or 1, right? So if it is 1, that means the expression is true. If it is 0, that means the expression is false. Okay, fine. So that would be the introduction to our chapter on operators. Why do we need operators? We need operators to manipulate data, to change data. We need operators to write expressions and statements. So if you write something C is equal to C plus 1, this is a statement. right? And in order to write this statement, you need two different operators that we have used here. And these are all arithmetic operators. This is an assignment operator and this is an addition operator, right? So these arithmetic operators are used to manipulate data. It's used to change the data. It's used to evaluate mathematical expressions. All right. Conditional operators, or basically when we talk about the relational operators, the relational operators will be useful in looping because they will specify the condition on which the looping should take place. Now, one very important property in your program is that your program should come to an end. Okay, that's one of the most important properties of a program. You should not have a program which runs forever. Okay, you can have a scenario in your program when you start the program, it keeps running forever without stopping. That's a problem. Okay, we should not get into a situation. Now, the program does not run by itself forever. Okay, it's important to understand that we write the code and only due to our mistake the programs can run together. So when I start a loop, one of the places where the program can continue to run forever is looping. So this is the dangerous part of your program, where if you don't write a loop properly, or if you don't execute, you know, the set of instructions again and again under a conditions, then there is a danger of your program running forever. Now, when that happens, you have to stop it. That means there is an issue with your code. Okay. Now, for example, when we start looping, right, every loop must have a condition. And this, depending on this condition, the loop either executes, runs, or it doesn't. Okay. Now, this relational operators play a very important role. So now what we are going to do in the next chapter is we are going to introduce this concept of loop, and we are going to see how we can make the program execute multiple instructions many number of times under a certain condition. Okay, it is very important. So in all the previous lessons that you have learned, right, you have learned the basics of how to write a C program. You have learned some important functions like getchar and printf. You have also looked at the standard IO. We have talked about the streams. I have told you what is a stream. I have told you about the input stream and the output stream and how they are connected to the standard input and output devices. And we have also learned some useful operators. Now, what we are going to start is we are going to start working or learning a very, very important feature of any programming language, and that is this one, or that is called as looping. Okay. Now, looping is not just associated with C programming language, but it is there and it has to be there in any programming language. So when we talk about fundamentals of programming, looping is a very important feature, and it is also called as iteration. Okay, iteration means what? Iteration means performing the same set of sequence over and over again, one by incrementing it one. So basically, I cannot, when I loop, I start from 0, I go to 1, then I go to 2, then I go to 3. So basically, 4 number of times, 5 times, 6 times. So every time that loop runs, you're getting incremented by value 1. Okay. So the value is incrementing by 1. That is why this is also called as iteration. Okay. So looping is a very important concept, and I hope some of you must have already done it, but all those who are doing the programming for the first time, please remember that looping is very important. Now, looping forms the basis of business logic. When I say business logic, what do I mean? A program, for example, if you are going, suppose you want to do some task. Suppose you have suppose you go to a bank, right? So when you go to a bank and you withdraw money, The whole purpose of you going to the bank is withdrawing money. So which is the core function of the bank where you're going to withdraw money? There will be a counter, and in that counter there will be a cashier who will be sitting, and he is the main guy who will be giving you the money. So you have to present him with a check. He will look at the details of the check. He will authenticate your signature. He will check if everything is written on that check in the proper order. If there are no mistakes, if everything is correct, then he will take that check and he will open the computer. He will deduct that amount from your account, right? And then he will hand over that money to you, and then he will close your account. So this is the most important process of withdrawing the money from the bank. So when you go to a bank, you're looking for that cashier. So this is a main function. The main function means that main business logic. Okay. So if I have to write a program, or if I have to define the steps in order to withdraw money from the bank, I will be writing the program, taking the cashier as the main guy, right? So this will be the cashier, and the entire program will be written around him. Okay. Now this means so the logic that I will write, in order to withdraw this, the logic that I will write to, define this program will be called as my business logic. Okay. So the main logic that I write in my program is called as business logic. Now this logic is basically the core functionality of my program. Why am I writing this program? What is the purpose of me writing that program? So remember, when I write a program, I have to include stdio. This is also a part of the code. Writing the main is also a part of the code. Declaring variables.
Sir, voice was break. Can you repeat it, please?
Okay.
This slide only.
Okay. So I was talking about what a business logic is. So business logic is the core functionality of that program. For example, if I have a function, or if I have a problem, right, where I want to find the square of two numbers. Square of two numbers, let me say, suppose I have number A and B, and I have to find A plus B. This is what I need to find. So this is my problem. Okay. So my main functionality is to find this result. But in order to do this, I have to write a code. So in that code, I have to first take A and B, right? And then I have to take say another variable C, and then I can write C is equal to A plus B to the power 2. Now I cannot do this in a program. I'll tell you exactly how to do this, but just for general information, I'll be writing this, and then I'm going to write print C, and then I end the program here. Now if you look at this small dummy code, right, which is my main logic? My main logic is this. This is my main logic, right? And this is the logic for which I'm writing this program. My actual work, my actual data transformation is happening here. I enter 5 and I enter 3, 5 and 3, but there is a data transformation is happening. So 3 plus 5, 8 square, 64. So my 3 and 5 gets converted to 64. The value of C was 0, and now the value of C is 64. So there is some kind of data transformation. So this is the main logic in my program, which is actually causing the data transformation to take place, right? So this logic can be called as a business logic. Okay, so this can be called as a business, business, business logic, because this is the business for which we are writing this code. But along with the business logic, you also have to write a lot of supporting codes as well. Hash include, main, int a, b, c0, print c. So these are all supporting codes. Okay, these are all logic which supports your business logic, but your main core functionality is this one, and this is basically called as the business logic. All right. So looping is that property of a programming language which will help you in defining your business logic, which helps in your business logic. Did you understand now? So most of your business logic will involve looping. Okay, so your business logic will involve looping. All these codes, allied codes, looping is not quite that important, but in case of implementing your business logic, you will need looping. Okay, so in today's class, what I'm going to do is I'm just going to introduce the three different statements which are available in C for looping. Okay, so in C, there are three statements, or you can say ways of looping. Okay, what are those three ways? The first one, you don't need to actually worry about it because we're going to do it in details. The first one is the while statement. Okay, the first one is the while statement. The second one is called as do while statement. Okay, so this is my second one. And the third one is the for statement. All right. So we are going to look into the details of what are the differences between the three. How can we use these three different statements to, you know, go ahead and do our looping. So we will explore these three different sections, and we will explore these three different statements one by one with an example, and we will see what is the purpose of this and how this helps us in writing our programs. So if anybody has a question related to this, then you can please ask me now. Anyone has any questions related to this?
No, sir.
No? Okay, fine. So
No,
if you
sir.
don't have, yeah, if you don't have any questions related to this, then we can end this class. But before you go, I would request you to share your roll number on the chat box. Okay, I think already many people have done. If you have not done, please write your roll number in the chat box and then you can leave the meeting. Okay, so I
Okay,
am
sir.
here. So please write your roll number in the chat box and then you can leave the meeting. And then we will meet again tomorrow and we will start discussing the loops one by one.
Yes, sir.
Okay.